Okay, so this is the VCAA sample questions. Question number 6. So we have a position vector of the sparrow, and we have an I component, a j component, and a k component. And find the value of t when the sparrow first lands on the ground. When the sparrow first lands on the ground, the k component will be equal to 0. So 4 root 2 sine of pi t on 2 plus 4 root 2 equals 0. And the reason that is that if up and down is k, when k equals 0. So on my calculator, I'm going to set that equal to 0, and I want to solve for the time. But because this thing will have many, many, many answers, I'm going to put a condition, and I'm going to say maybe 0 up until x, because there's a pi there. X is likely to be without pi, so I might say 10. And select it all and go interactive advanced solve for x, and I get 3 and 7. Therefore, t equals 3 is the first time. Okay, part B, find the distance the sparrow is from the origin when it first lands. So I want to know how far from origin at t equals 3. So r of 3 will be 23 times 3, which is 69 in the I, 5t, so 15 in the j, plus, well, I can grab all of this and make, that's going to be 0, because that's when it lands. So we're going to be, the magnitude of r of 3 will be how far. So it's going to be the square root of 69 squared plus 15 squared, and that's going to give you an answer of 1 decimal place 70.6 centimetres. Okay, part C. Do I have a part C? Okay, part C, find the maximum flight speed. So what I want to do is I want to find the speed, so I want the velocity, and the velocity will be a derivative. So r dot of t will equal v of t, and that's going to equal, let's grab this, copy this, so v of t is going to be the derivative of that, which is 23 in the I, plus 5 in the j, plus 4 root 2 cos of pi t on 2 times pi on 2. And I'm interested in that's going to be v of t equals 23i plus 5j plus the 2 will cancel 2 root 2 pi cos of pi t on 2. And the magnitude of the velocity, that is the speed, will be 23 squared plus 5 squared plus 8 pi cos of pi t on 2 squared. Now, it could be maximised. However, I know that this will be a maximum when this is the biggest it can be, because that's constant, that's constant, that's constant. So the largest that a cosine can be is 1. So my answer should be the square root of 23 squared plus 5 squared plus 8 pi. The minimum will be when that is going to be equal to 0. So on my calculator, I'm going to do, I've got a square root there already, 23 5 plus 8 pi squared. and that gives me 25.1586, and I'm wanting it to 1 decimal place, 25.2 centimeters per second, I imagine. That's AB.